Hi to all. Now today's topic, how to find out the effective resistance in series and parallel combination, right? The problems on series and parallel combination. And now first we will let us discuss one problem, right? Find the effective resistance between the A and B. This is point A, this is point B. Between these 2 points, I want to find out the total resistance, effective resistance, right? If there are several resistors are there, if combinedly if this act as one resistor, then what is the effective resistance, right? Then for that we have to use one method here, which is parallel and which is series we have to find out. In this method we have to use one method we have to use, that is successive simplification method, right? There are several methods are there to simplify. Now I will tell one method, that is successive simplification method. Then what is this successive simplification method and how to simplify this complex circuit? If we see this, it was very difficult for us to find out whether they are parallel or series or whatever it may be, right? If we will simplify, right, step by step, then it will be very easy. Let's go. First we can take these 2 points P and Q between these, and then we have to find out the effective resistance between these three, right? Look at here, and now I will redraw this diagram between P and Q, right? This is 2 ohm P, and this is 2 ohm, and this is again 2 ohm. This is P and Q. Can you find out the effective resistance between the P and Q? Yes, what you will get? These three are whether they are in series or parallel. How to know whether they are in series or parallel? In series combination, current is constant. In parallel combination, current divides. In series combination, only one way will be there. Okay, for example, here we are seeing this is a diagram. Okay, this is 2 ohm and this is 3 ohm. Okay, we will see that this is between A and B. What is the effective resistance? This is series or parallel? Only one way, right? Current is passes like this, right? There is no division of current. There is no two ways. That's why these two are in series. And the same position like this there. This is 2 ohm. Okay, look at here. And this is 3 ohm, right? Okay, this is A and this is B. Find the effective resistance between the A and B. What is the effective resistance between the A and B? In this case, effective resistance between the A and B is 2 plus 3, 5 ohm we will write. Why? Because they are in series. Find the effective resistance between the A and B in this case. Then how to find out the effective resistance? Look at here. Here the current does not divides. The same current passes, right? Same current passes. That means current does not divides. Current does not divide means there is no change in this diagram and this diagram. Only we are bending this one like this, right? And that's well. Here again one way is there. Current does not divides. When you will see this diagram, this 2 ohm, 3 ohm appears like parallel, but they are not parallel. And this is also series combination. And this is also series combination, right? And simply by seeing the diagram, we cannot say that they are series and they are parallel, right? And we have to check whether the current divides or not. Look at here, if the current it's applied at A, it will go like this and it will not divides. That means current does not divides means this is a series combination, right? In series combination, effective resistance, how we will find out? R1 plus R2. We have to add 2 plus 3, that is 5 ohm we will get, right? That means this is the series and this is also series. Just by seeing the diagram, these two are appearing like parallel, but they are not in parallel and they are in series because current does not divides. Okay, you must remember this point. When current divides, if current divides, that is parallel combination. If current is same, then that is series combination. Okay, I will give in the note point also. Right, look at here, I will write in the note. First we have to find out the effective resistance here, that is R1 plus R2 plus R3. Okay, or otherwise this is identical resistors, 3 are identical resistors. Then we write NR, right? If n identical resistors, each of resistors are connected in series, then NR is the series effective resistance, N is the 3 and each resistance is 2 ohm. Then what you will get? 3 into 2, 6 ohm we will get. Effective resistance is 2 plus 2 plus 2, 6 ohm we will get. And now here this is equivalent to 6 ohm. That means this diagram we will write like this, and the effective resistance between the P and Q, we got effective resistance between the P and Q. This is P and this is Q. In between the P and Q, effective resistance we got is 6 ohm, right? Between the P and Q, the three resistors combinedly act as one resistor and its resistance is 6 ohm. right? Now this 6 ohm is the effect resistance between the P and Q, that is just we find out, right? Like this we have to attach it here. Now we have to draw the diagram, right? And now this is A and this is 2 ohm and this is B. Same diagram we have to draw. Okay, look at here. This is I drawn the diagram, right? Redrawn the above diagram like this. Okay, this is P and this is Q. Between the P and Q, the total resistance I drawn it here, that is 6 ohm. And now again we have to find out the effect resistance between these 2 points. These 2 points I will take as R and S. Okay, now I want to find out the effect resistance between the R and S. And now we can draw separately that R and S, right? And for that, this is R and this is S, and let us see, this is what, 3 ohm, and this is how much, 6 ohm, and these are the 2 resistors where they are in parallel or series, right? This point I am taking R, this point I am taking S, and this RS right side part I drawn this one at here, and then I will find out the effect resistance of this, and then I will attach it here, because these 2 resistors will act as one resistor. Its effect resistance I am going to find out. Then how to find out the effect resistance? These 2 are in parallel, right? 3 ohm and 6 ohm are in, right, parallel. Now in parallel effect resistance, how to find out? Effect resistance between the R and S, right? Effect resistance between the R and S, that is R1 R2 by R1 plus R2. This is the formula for the parallel combination. We have to use it here. That is 3 into 6 by 3 plus 6, 18 by 9. What you will get it here? 2 ohm we are getting, right? The effect resistance between the R and S we got is 2 ohm. Again we have to attach 2 ohm it here. Then we can redraw the diagram, right? This point is A and this point is B. If you redraw the diagram, we will get this as 2 ohm and this as 2 ohm, and this is 3 ohm. This is again 2 ohm. This is again 2 ohm. And between R and S we find out the effect resistance, right? What is the effect resistance, that one? Yes, between R and S these 3 are in parallel, right? We got 2 ohm. Okay, look at here. Here we got the 2 ohm. We find out that one. And now here how they are in parallel, how we tell that they are in parallel, right? If you supply the current at here, that after coming to this point the current will goes this side some I1 and this side it will goes I2. That means current is divides, right? The current divides means that is parallel combination, right? Note, that is if the current is the same, right? Current is same means that is series combination, right? And the current divides means that is parallel combination. Okay, right? It was very simple. Now we have to find out the effect resistance between the, again we will take this part, we will take not this one, we will take these points. Okay, R is completed. This we can take as T, U we take. Okay, between the T and U effect resistance we can find out. Okay, effect resistance between the T and U. Yes, what you will get? Again these 3, this part already we know. This part is similar to this one. Then we can find out the effect resistance between the T and U is what? 2 plus 2 plus 2, or NR formula we can use, but because these 3 are in series, if you remove this part and you draw again, then we will get T U at here same as this. Then we will get effect resistance as 2 plus 2 plus 2, that is NR formula we will use. right? In series combination we have to use NR formula for the identical resistors. Okay, R1 plus R2 plus R3 and so on Rn. All are identical means R plus R plus R NR we will get. 3 into R is 2. What you will get 3 into 2? 6 ohm we are getting. Right? 3 into 2 is 6 ohm we are getting. Then again 6 ohm attached. Redraw the diagram. Okay, this is A and this is B and this is 2 ohm and this is 2 ohm. This is 3 ohm. Between T and U, effect resistance. Between T and U, here, between T and U, effect resistance. These 3 resistors combined act as one resistor. Its resistance is 6 ohm, right? Then we have to find out the effect resistance between these 2 points, right? Again, we have to split it here. For example, this is VW. Okay. But then effect resistance between the V and W, what you will get? Okay, these 3 and 6 are in parallel. We have to use R1 R2 by R1 plus R2 formula. Then what you will get? Right, 3 into 6 by 3 plus 6. 9 by 18 by 9. Then we will get 2 ohm. Then we have to add effect resistance between the V and W as 2 ohm. Then again we have to draw the diagram. Right, this is 2 ohm. And next this is 2 ohm and the next effect resistance between the V and W, what you got here? 2 ohm we got, right? Okay, now what is the effect resistance between the A and B we want? It was very simple to find out the effect resistance between the A and B. 2 are in, okay, between the V and W effect resistance we got, this is V, this is W, right? Effect resistance we have to find out NR. Then R is 2 ohm, N is 3, R is 2. Then final answer is 6 ohm. Okay, and no need, in the competitive exam we will not take this much time to solve the problem, right? We will simply we have to solve within 1 minute. Okay, how to solve this problem within 1 minute? Look at here, if you know everything then it was very easy. Firstly we can go for this 2. These 3 are in series. Effect resistance is 6. This is 6, this 3 are in parallel, right? 6, 3 effect resistance is 2, right? This 2 are in series. Then series effect resistance is 2 plus 2 plus 2, 6. And this 6 and this 3 is again parallel. Then in parallel effect resistance is 3 into 6 by 3 plus 6. That is again 2 ohm. Then here effect resistance is 2. Then 2. Then that is total effect resistance is these two are in parallel as in series. Their effect resistance is 6 ohm. Like this we can find out simply, right? And this is the successive simplification method. Let's go for one more problem based on the series and parallel combination. Okay, this is our next question. Find the effect resistance between the A and B. We are going to find out the effect resistance between the A and B. There are 3 resistors they give, right? This is R1. R1 is equal to 6 ohm. And this is R2, 6 ohm. R3 also 6 ohm. There are 3 resistors they give here. Now we have to find out the effect resistance of these 3 resistors. Right? Effect resistance between the A and B is what? That is our question. And now this is the previous CBSE question, right? Previous CBSE question, very important. Then how to find out the effect resistance between the A and B? This is one method I will tell it here. Okay, first I will take this is a resistance. Actually, when if there is no wires, if these wires are not there, right, here like this it will be there, 6 ohm and 6 ohm and 6 ohm, right? And here this is a wire conductor, right? And here directly these are in series and we can find out the effect resistance. 6 plus 6 plus 6 plus 6, 18 ohm we will get when there is no this conductor, right? Due to this conductor the effect resistance will be changes. Then how to find out the effect resistance? Let us see how to find out the effect resistance in this case. And for that we will take like this. I will redraw this diagram. This point I will take as 1 and 2, 3, 4, 5, 6. Okay, I will take the ends of the resistors as like this. For this end 1 2, next 3 4, next 5 6, like this. First A, I will redraw the diagram. Redraw the diagram. Okay, solution. Let us see. Very simple it is. From A you should start. Okay, this is a conductor. There is no potential difference between this point 1 and point 4. Okay, actually there is one method is there. Here this conductor is a, this conductor zero resistance, no resistance, means between this point and this point potential difference is zero because it is connected with a conductor. Conductor means potential difference we called IR, but resistance is zero means potential difference is zero. This point and this point has same potential. Now the same potential points can be combined. Okay, and that is one method is there. I will tell in easy way. Okay, start from A. Okay, A is connected to the first resistance, first part, left part of the resistance. Okay, 1 ohm, 6 ohm. This is connected to the 1, right? This is connected to the 1 and 1 first resistance. Okay, and this point we can take as 2. And next A is also connected to the 6 ohm, right? 4 point. A is also connected to the 6 ohm, that is the point 4, right? Point 4, and the point 4 end is 3, right? This is 3. And the next A is also connected, directly connected through the wire, right? Conductor to the 5. Now A is connected to the 5. This is connected to the, A is connected through the wire, right, to the 5. A is connected to the 4. A is connected to the 1, right? And 1 4 5 are at the same potential because point 1, point 4, point 5 are connected with their conductor. Then potential difference is 0. When potential difference is 0, then they are connected to single point. And the next, this is 1 end is 2 and 4 end is 3, 5 end is 6. And now look at here, 2 3 are connected to the 6 and the 6 is connected to B. 2 3 are connected to 6, 2 3 are connected and they are connected to 6 and their combination is connected to B, right? This is the equivalent circuit diagram. That means what happening at here? Tell me, these three appears as a series, but when you connect with the conductor, then they will become parallel, right? That means now 6 ohm and 6 ohm and 6 ohm are in parallel combination, right? Are in parallel combination. What is the effect resistance in the parallel combination? Effect resistance in the parallel combination is, right, direct formula we can use R by N, right? In parallel combination, Rp is equal to R by N, right? In parallel combination, effect resistance in case of identical resistors, R is 6, by number of resistors are 3, effect resistance we got 2 ohm. Or otherwise you can use general formula also, that is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That is 1 by Rp is equal to 1 by R1 is 6, 1 by R2 is 6, 1 by R3 is 6, 1 by 6, right? And then we will get 1 by Rp is equal to, this is 1 by 6 plus 1 by 6 plus 1 by 6, 3 by 6, right? Then Rp is equal to 6 by 3. Rp is equal to 6 by 3, that is nothing but 2 ohm, right? Solution completed. And let us go for this, right? This is a capacitors. Then how to find out in case of capacitors? Let us see, there are 3 capacitors are there. Now how they are connected? The same method is there. Simply without telling anything we can tell that the C1, C2, C3, these 3 are in parallel because of this connection, same as this, right? Or otherwise you can also do like this, same combination we can explain like this. This point we can take as 1. Okay, if A is given to the positive, if A is positive, look at here, A is positive, right? Okay, this plate will become positive, okay, and then this is the conductor, right? And this plate also becomes positive, and this is positive, and this plate also becomes positive. And if you will give this to the negative, B is connected to this point, negative, and the B is connected to this also, negative, right? And B is also connected to this point, negative. If you redraw the diagram, okay, A is connected to this plate, okay, this plate. First A is directly connected to this positive plate. 1, 2, we will write 1, 2, 3, 4, 5, 6, right? And let us start. A is connected to 1, first plate, that is positive plate, and 1 is combined with the 2, okay. And the next, A is also connected to fourth, right, fourth plate of a capacitor. This is 4, and 4 is combined with the 3, one capacitor. A is also connected to the 5 through the wire, right, and this is 5, and this also plus minus. This 5 and 6 gives one capacitor, and we can combine this side. Why we can combine this side? Because 2, 3 are connected, right? 2, 3 are connected, 2, 3 are connected, and their combination is connected to 6. 2, 3 connected, and their combination connected to 6, and 2, 3 combination connected to 6, and their combination connected to B, right? This is B. Simply, no need to explain again. Actually, already I explained it here. Simply once again revision I explained it, okay. And here these 3 capacitors are in parallel combination, right? And now the capacitors are in parallel combination, okay. Now what is the formula to find out the effect resistance in the parallel combination? In case of resistors in series, okay, effect resistance formula is R1 plus R2, right? And parallel combination, in parallel combination, what do we write? 1 by Rp is equal 1 by R1 plus 1 by R2. But what about the series combination of capacitors? This is for resistors. In case of capacitors, series combination 1 by Cs is equal 1 by C1 plus 1 by C2. Parallel combination, right? Cp is equal C1 plus C2, okay. And capacitors are in parallel combination, but the formula in the capacitors is reversed to the series. It is similar to the series combination of resistors, right? In the parallel combination, we have to add them, C1 plus C2 plus C3 we have to use, or otherwise NC we can use. That is 6 plus 6 plus 6. Here we will get as, what you will get, tell me? 18 microfarad we will get. Or otherwise we can use this formula also, NC. N is 3 capacitors, each capacitance 6, 18 microfarad we will get, okay? Right. And now let us go for one homework I will give and try for it. Look at here, this is homework. I gave the 3 questions as homework. The first one is find the effect resistance between the A and B. Between A and B we have to find out the effect resistance. We have to use the successive simplification method, you remember it. Same method as the first problem. But here what about this? This is not a closed circuit, right? This end is not closed. And the current starts from here like this, it may goes, but here it will not goes the current this side. This is not closed, only current will current flows only in closed path. That's why in this part current does not flows, because here it is an open circuit. After going to this point, then current never goes in any direction. That's why in this part current does not flows. Directly we can remove these two parts. And because why we can remove these two parts? These are not a part, these two resistors not in a part of closed circuit. Only in closed circuit current flows, right? That's why this will remove. Okay, we will remove this one. It will not keep any resistance, because through this it will not current does not passes. If current passes, some resistance will be there. Current does not passes through this 3 ohm and 2 ohm because these are not in a part of closed circuit. Okay, and you can remove this, and remaining part these three and these three you can combine and you can find out that one. Next one is a wire of resistance 8 ohm is bent in the form of circle. Okay, there is a straight wire is there. Okay, this wire has the resistance 8 ohm. This is bent in the form of circle, right? This is bent in the form of circle, and they are asking to find out the effect resistance between this point across the diameter. This is, for example, this is the diameter. This wire is bent in the form of circle. Across the diameter, they are asking the resistance, right? And you can find out the diameter. If across the diameter effect resistance, you can find out. A wire of resistance 8 ohm. This is a wire, straight wire. Its resistance is 8 ohm. That is a straight wire. This is a straight wire. Okay, straight wire of resistance or a wire of resistance. We can take a wire, no problem. A wire of resistance 8 ohm. It is bent in the form of, right, in the form of circle. Then find the effect resistance between the A and B, that is across the diameter. Next question is find the effect resistance between the A and B. This is A, this is B. In this there are 3 2 ohm resistors are connected right here, 3 6 ohm resistors are connected right here. Then effect resistance between the A and B we have to find out. Okay, and today itself I am expecting the answers from you, right? And if you got the answer of question number 1, you can write that answer in the comment. And if you got the question number 2, then you can write the answer in the comment. Okay, I am expecting the more comments. I am expecting the answers from everybody today only, right? And whenever I am taking the much struggle to make the lectures for you, right? And then in the summer, then you have to do some work and you have to try for the solutions and give in the comment, and also comment about my lecture, right? Thank you for watching my lectures. Till now, if you not subscribe my channel, I am expecting you to subscribe my channel and also share my channel to some of your friends, and then our channel will promote and our channel will become popular, right? And all the members will get benefit from me with the physics classes. Thank you.